Hello everyone and welcome back to this course online. Just few information I want to highlight before we move on to this topic today. The first thing is still our course is going online and we might have the extension of our course. So there will be more updates in the days to come about whether we are going to have online or offline. So just watch out for the announcements. And moreover, initially I was planning to give a homework that is based on the machine learning methods, but I got some feedbacks, good feedbacks, as well as some suggestions for this course. Most students, they said that some of them are not familiar with Python programming, and many of them are not familiar with especially using the tools like Numpy or pandas and other libraries in relation to the data science. So they find it hard when I gave this first assignment, and as I asked for feedback, I was encouraged, or in other words, I was suggested that to give detailed description of all the programs. In fact, I gave a very basic outline in the last example, and it seems after the basic explanation of standard deviation and mean, variance, then when I talked about linear regression and so on and so forth, it seems people got struck and they're not following it very well. So I decided to make another video which gives you, series of video which gives you all the basic things that you need for data science. From the scratch, we are going to see all the basic things for NumPy, pandas, and so on and so forth. And the last video, we also had another problem, it seems like in LMS, almost everybody found that the video got struck at some certain point, maybe after 48 minutes, I think. Yeah, 48, 49 minutes, it got struck and you can only listen to my voice. Anyway, the remaining part, what I did is about using the COVID data science. COVID data set. I was using that as an example to highlight. I will use that example later on once you understand how to use these packages like NumPy, pandas, and other things. Yes, once again, welcome to this course which is offered online, and today our focus is on introduction to NumPy. So what is NumPy? Well, you might have already come across this term, NumPy. It's simply a library of Python programming language, but it adds support for large and multi-dimensional arrays and matrices, along with large collection of high-level mathematical functions. So there are many other mathematical functions which are not easy to program in just one line or two line or even few lines. So here we are going to use these libraries, and they are going to really help us in faster programming. Especially we are focusing on certain algorithms. We don't want to write all the algorithms. There are a lot of inbuilt methods. As NumPy, if you want to perform the matrix operation, yes, we can easily do it matrix and array operations by using this, by importing this NumPy. We'll see some of the examples of NumPy, how we can use it in real time. When I say real time, we can see the sample program in today's lecture. And the following series of lectures, we are going to talk about how we are going to use other related libraries which are meant for data science as well as machine learning. Well, let's begin with the first example here. Okay, let's start a new one. Well, okay, I think I will just delete this so we can start out as a new one. So for those who are not familiar with the environment which I'm working right now, it's nothing but it's actually the Jupyter notebook. It's very interactive environment. You can see what's going on now and then. Okay, let me create a new one. That's better. Okay, because that one was I was working as an example to show pandas and numpy. Okay, the first thing that you're going to do here is to import. So as with other programming languages, we always have header files and other things, libraries to be imported. Likewise, same as that, this numpy is again a library. So we are actually importing the numpy library, and this was originally created by Jim Honin. Is a person initially who was working on implementation of Python for Java platform. It's called Jython, and for Microsoft .NET platform it's called Iron Python. So yeah, some of the several contributors you do have for this numpy, and if you want to contribute in the future, for example, if you want to contribute to this numpy library, you can also do that. Yeah, so numpy we can import it as np. So whenever now I use the word np, it's going to refer to numpy. So let's talk about some array. Let's say a equals np dot array, and in this array let's take certain values like 100, 250, 430. Okay, fine, we got this array. And if you want to print this array, you just have to, and for doing that, in fact, for doing that, I just did shift enter. So your array contains 3 elements, 100, 200 and 450. That is the very basic operation. Let's go further into it. Say for example, you want to have another array, say b equals np dot arrange. You're going to arrange and 20. It's just like a range in the general Python range. It just returns an array. I'll come back to this range again, but for the time being you can get this out like you can, yes. So it prints out all the values with that range of 0 to 19. In other words, it's like 20 parts are being arranged. So that's the simple aspect. And if you can perform more other information, even if you want to know what is the current version of the numpy that I'm running, for example, if you want to print out numpy version, because this has been updated every time. Okay, so the command is not verified. Okay, this has been updated, so let's move on and we'll get this done as we proceed with other examples of numpy. Anyway, as far as numpy is concerned, one of the feature of numpy is to create an array. That's one of the feature of numpy. And as I told you, we are going to have one aspect is called ND array. So it's one of the cost functionality of numpy, that is ND array, which means it's an n-dimensional array of data structure. So let me put it this way. We have n just we put n dimension. Yeah, that's an n-dimensional array. Data structure. Let's we can put it here. ND. In other words, by default, if you just call ND array, it's like just an array in other programming language. So it has many advantages. It's like, for example, if you want to build any dynamic arrays or arrays, if you want to view any arrays, if you want to buffer things from the array, all the operations can be done with it. So this functionality, you can also exploit the functionality by means of SciPy. We will talk about it in another time, how SciPy can also be used along with this ND array. So let's see some example of this ND array, how it can be used in this with this Numpy in view. Let me put it this way. Okay, we had A, B. Let's update. So let's say, okay, we have A. It's 250. I thought 430. In fact, we had a similar issues. So let me skip these two parts here. And let me call this as C. Yeah, you got me. That's NP. Well, in just how to create an array, and we also saw how to have this range. Let's quickly check this out. And as far as Numpy is concerned, we have the Numpy creates this basic array, which is called ND array. And ND array is just an array function in other programming language. It's a built-in Python function that tells us the type of object that you have passed to it, and it has actually make it as an array, which works with this Numpy. So we are going to see this is just an array again. We are going to print this. Here we have referred this as C. In fact, the initial value was A. Now I have changed to C. Anyway, let's proceed on how to print different dimensions of array. So array can be of any dimensions. Let's say if I have, say, just 100 here, we can call it as just like 0th dimension. And if we have, say, two elements there, that's it. It's like a 2D, or in other words, it's like 1D array. And for 2D or 2 dimensions, we may have to go for 2 different values, in fact. Yeah. Let me clarify the errors here. we may have to put the whole bracket. Yeah, so that's it. So now we got the 2D array contains two arrays with these values like 100, 200, and then 300, 400. It's a two-dimensional array. So we can also have, in the same way, three-dimensional array. Can you make it? Yeah, let's try again. With the two dimension, I'm going to extend it to the third dimension. So one inside the other one. So if you watch closely, you will find that all the opening brackets has a closing bracket. So if you miss any one of them, as I forgot to put one earlier, you may also end up with some errors. So as this is a very simple code, you would be able to decode it. In other words, you will be able to debug it. But if it's a larger code, it's not easy for you to proceed. Okay, let's have here it's 250. And then you have another one. Let's call 430. And you have, say, 40, 50, 55, 20, 30, 35. Is all the brackets closed? Probably, yeah. Okay, so let's closely check whether we had all the brackets closed. You can check it out. Mistake I made here, maybe here I forgot to put this comma. Well, now it works. There we are with the third dimensions. So every time we can check you're in which dimension. Let's do this example here. Let's consider another variable. Let's take another variable, say, let's change it back to A. Then you have B. Let's put this as B. That is, okay, we need another one. C. Okay, let's order it likewise. B and C. We have A. For we had two dimension, one dimension, and we also need to have a zero dimension, for which let's try to use a simple example here. Fine. So let's try to check everything out. Maybe I'll put x equals np dot. So n dimension gives you the dimension of the array. Here we are. So we can check the dimensions of the array. An array can have any number of dimensions, just this n dim, which is the argument that we are sending. So when array is created, you can define the number of dimensions, or you can check the number of dimensions using this argument n dim, n dimensions in other words. Yes, you can also create an array with even 5 dimensions, and you can verify. So that's an interesting part, right? If you like to create a 5-dimensional array and you can verify it, let's check this out here. Okay, y equals, let's say we have the 5 dimensions. Okay, if you want to change the values, you can change. We'll just put it as dimension. Here it is. So now if you closely watch, this is an array. The innermost dimension is the 5th dimension, the innermost dimension, which has 4 elements, 11, 12, 13, and 14. The 4th dimension has 1 element. It's a vector actually, because it's like a one row vector. And the 3rd dimension has 1 element, that is a matrix with that same vector. And 2nd dimension has 1 element with a 3D array, and 1st dimension has 1 element with a 4D array. So that is the basis here we have. So now is that we have getting used to the arrays and how we can use arrays. Well, let's play along and let's see more information about how we can go on and check various other ways. For example, it is also necessary for us to index the array. How do we index the array? For example, how do you index a 2D array? How do you index a 3D array, and so on and so forth. Let's try to find a way to do that. So you have, let's use the same examples similar to this. So you have NP array, and you have this array given. So if you want to access the 2nd element of this 1-dimensional array, you can try to print this out, like print the 2nd element. Yes, the 2nd element has been printed here. There it is. So again, when we talk about indices or index, as with many programming languages, the index starts from 0. So later on, whenever we use, you can always try to recall this. Every time the index that we have here always starts from 0. Okay, let's move on and let's see how we can access more. Okay, let's take this here. We want to print the fifth element of this array, and it's got to be, there we are. Here's the fifth element of the array. Okay, so here is the question for you. So initially I said that it is a one-dimensional array, just the element from that one-dimensional array. And now I'm telling that you are going to access, okay, let's put it this way. This is the second element of the one-dimensional array. And now we are going to access the fifth element of two-dimensional array. There we are. So as you can check, the index starts from 0. So 0 is your first dimension here, right? And 1 is your second dimension. So in other words, this is row and column. So we always consider row and column. So row, when we talk, it starts from, anyway, both row and columns index starts from 0. So when I say 0th row, it's the first row. And when you say here, the first row is actually the second row that we have here. So in second row, the fifth element is 10. That's what we got here. Well, let's go deeper and let's see how we can access the three elements. I mean, in other words, three-dimensional array. So we had the example of three-dimensional array here. Let's use that, and let's try to evaluate these values here. Okay. So when we talk about 0, 1, and 2, can you guess what is going to be printed? So we have three dimensions now. Yeah, 0 is going to be your, you know what is 0. 0 is just your first row that represents the 0. And as we move forward with that, 0th row, what is the 0th, or the, in other words, what is the first dimension among these three dimensions? Yes, the first dimension contains this whole structure here. That is your first dimension, right? And this is the part of the second, but in other words, when we combine this together, it becomes the 3, or in other words, the third dimension, so-called the third dimension. So let's briefly see how it works. So when we selected 0, we are in fact selecting this two parts, that is 100, 200, 250, and 300, 400, and 430. This is what we are selecting. And then when we select 1, which is next, we have to select between these two. This is 0 and this is 1, correct? This is 0 and this is 1. So we have to select between these two, which is selected as 2. So we are now, right now we are here. And in here, you're going for the second element, which is 0, 1, 2. So 430. So that's what we are expecting right now to print 430. Did you understand this point? Because these are very crucial for you to understand. Unless you understand this arrays here, there's no point in going into the machine learnings or any other parts of data science where we are going to access certain data. And if you're not sure how to access the data, it's very hard for us. So we should be able to understand multi-dimensional array. Later on, we'll also check some examples on how we can reduce the dimensions using various methods. But for the time being, it is essential for you to understand how each dimension works. So as I told you, the 0 part is this part. When compared to, I'll put it this way, it will be easier. So this is your 0, and we have chosen, in the third dimension, we have chosen this part. Then comes the second one, which is 1. For 1, among this, we are choosing this is as 1 because this is 0 and this is 1. You are choosing this. And then you have 2. For 2, you have to go for 0, 1, 2. So that's why we have 430. Okay, once you understand this, the basic parts of array elements are easier thereafter. Okay, why don't you try to print some more elements and see how it works. Maybe you can try different modes. For example, maybe you can try, say, let's say you have this array here, and then you're trying to print so I will leave this to you. You can check that out, right? So there should be something that you have to check, and how you would also understand how it works on the other hand. Now let's go to the second part of this lecture, which is slicing of arrays. Slicing is again an important aspect of array operation. So slicing in Python means taking elements from one given index. You have one index to another index. You're going to try to see how from one index you're going to give to another index. So we pass slice instead of index. You're not going to index it, but you're going to have a kind of slicing. In other words, it's like it looks like this: start and end. In other words, we can also say it is like start, end, stop, something like that. Start, end, stop. Okay, let's take the same examples we have seen earlier. All right, let's take this example here. Now I have this array, and if you want to print this one, so what you can expect here. Let me increase the number of values for you to comprehend how it works. Okay. There you are. So the start position is 1 and the end position is 5. In other words, start position is like 0, 1. This is the start position, and you're going to end at 5. 2, 3, 4, 5. So that's how it has been printed. So in other words, you are actually slicing this array into some specific range. Yeah. So this is also very effective because at times we have to limit the operations of the data. You just need certain range of operations between or after, before, and so on, right? So unless you know how this works, it's very hard for you to analyze it. First of all, you should know how the array operates, which means that you should know exactly how the elements are distributed or arranged in the array. Once you know that, the second step is how to access these elements. And also you should know how specifically I can mention that within a particular range of data I have to access to perform certain operations. Let's do further on this. How about this one? How about this one? Here we are. So you can see the range starts from 4. In other words, this is the starting position. The end position is not given to us. So it will start from 0, 1, 2, 3, 4. So it starts from 4, which is 600. Then it ends till the end. You don't have to mention the last one. You just have to say 4 colon, which eventually represents that's the last one. So likewise, there are a lot of other things you can do by means of slicing. Again, the same thing can be reversed, right? Print A. There we are. Okay, I hope you understood what is happening, right? So which means that it is going to print from 0 to 4. So that's it. 100, 200, 430, 500. These are the first 4 elements. In other words, 0 to 4, first 4 elements is being printed, inclusive of, the elements before 4 is being printed. So that's why we have only 4 elements. Then again, there are a few things that I want to let you do, and you can try to understand what is the significance of negative slicing. So slicing, when you do the negative part, we will see what happens here. Okay, so slice from the index 3 from the end to index 1 from the end. So slice from index 3 from the end to index 1 from the end. So here is little tricky part. As you can see, that's how it is done when you use the negative slicing. So likewise, you can also index in several different ways. Okay, let's put another one here. Print A 1:5:2. Can you recall what it is? Yeah, start, end, and stop. That's what this implies. So when you try to run this program, you can find it starts at 0, 1. This is the starting point, right? It starts there. That is the one place it is starting. Then the next one is to end, where we are ending in there. There it is, your ending. After 2 elements, your ending. That takes you there. So to understand further on this, you can use more slicing. This also implies without giving any advice, you can clearly see that it returns every other elements from entire array. So it returns every other elements from the entire array. So you can see the second element, which means that these 2 elements, that is 1, 2, and these elements are missing. Apart from that, all other elements are returned. Yes, returned every other elements, just like that. So 0th element is returned, 430 is returned, 600 is returned, 800. You're just skipping or jumping 2, 2, 2, like 0, 2, 4, 6. You're skipping, or in other words, you're jumping. That's what I mean when I say return every other elements. Okay, we can also perform a lot of other operations. You can try doing it, for example, 2-dimensional array. You can try to perform a similar operations for the same. Let's take this 2-dimensional array and let's try to perform simple operations here. Print here again, you can see the second element. From the second element, the slice element from index 1 to 4. So when you say index 1 to 4, 4 is not included. So the first one, it shows that the second element which is this part, the two-dimensional array, and in here we are going to go from 0 1, that is 7 8 9, right? 1 1 is to 4, so it is 7 8 9, so that's what it is. And always remember the index starts from 0, right? So when I say second element, the index is 1, so don't get confused. You should remember all the way of your programming experience. And let's perform more operation with this. Let's say I'm going to print A, and in this case I'm going to use 0 2 and 2. Now can you guess what is going to happen? Yes? Yeah, from both elements, here from both elements, return index 2. So the index 2 is 3 here, index 2 is 8 here, so 3 and 8 are returned because we are taking from both elements. So that's how we are going to relate. Now let's move on and check further on giving more precise operations, array operations. So it's kind of a mixture of both that we've just seen. So here again, here we are having two dimensions again, like 2 3 4, this part 2 3 4, the first element is printed, and then the 7 8 9 is also printed, so the fourth is excluded. So when I say 1 is to 4, the fourth element is excluded there in that instance. So that's one of the features of the slicing. And apart from slicing, there are also many different data types you can use to do. For example, you have print it is integer type. You can see D type is used. So Numpy array object has a property called D type. This is the D type that returns the data type of the array. So there are different data types you can mention. You can also check how it works if I say, let's have it as a new one here. So let's say we'll change some values for this array. What is that? Robert, Ben, and say Kim. Yeah, as you expected here. So what is the error? That array spelling mistake. Okay. So you can see the data type of the array containing string is mentioned, and supposedly they have simple informations. Sometimes when it says U, it can also define, like sometimes it's defining U or I or F can also implies that a data type is a string. Let's also define, actually we can also define these data types as such. Finish with this example here. Okay, let's move ahead and we'll examine other aspects of this things. For example, even the array can also have Boolean values. Not only strings, it can have Boolean. There are a lot of different things the array can take. Let's briefly say what are the different things that it can say. For example, like we talked about integers, Boolean, unsigned integer. In fact, when we say u, it's like an unsigned integer, float, or it can also be time delta or time date informations, objects, strings, or in other words, in fact, a small u is the unsigned integer is small u. The capital U is supposed to be the Unicode string. So we call capital U is the Unicode string, which we have represented here. And there are different other types of things used in Numpy. For example, even you have the function in Python with complex, float, Boolean, integer, string. Here again, in the Numpy, when we use Numpy, we can also express the same thing by means of a different way. That's the key part. Now let's move ahead and see how you can copy the arrays and display different informations from a particular array. Let's carry on with the same examples that we are doing here. Let's start from here. Okay, I will have this array. Let's say b equals a copy, and then so what you can expect, yeah, so we can see we have changed the 0th element of a, that is 100, to 60. Then I am printing a, then I am printing the b. B is again nothing but we are copying the array. So you should always make sure whenever you copy, it is always better to keep the original one untouched. So copy should not affect the change made in the original array. So we should be careful of that, because sometimes I found even the well-trained engineers, they make a simple mistake. Just like this, they make one change here and then they go on to several codes, and they found that they thought the a is still 100, 200, 430. But just be careful, like when you make, there are some changes happening in the array. So again, if you want to see how things works, let's look at different aspect here. Let's say we have another one. In this case, we had a copy. Let's go here. Let's take the same element. And you have b as a dot view. It's another property we are going to highlight here. Let's say 0th element is equals to 80. Print a, print b. As you can see here, make a view, or in other words, change the original array and display both. That's what we are doing, and we should make sure that this again doesn't affect the original change. If you notice further down the road, in this place you can notice that how b is being viewed, unlike the earlier one, because there is some difference you could see when you use the copy function and when you use the view function. When you use the view function, even after using that, you change the a value, and again that is reflected in b as well. Let's move ahead and let's do further similar thought on this, but in this case we are going to use b itself. Let's say b of 0 equals, say, 90. Yeah. Print a and print b. Right. So can you see here, this is vice versa. When we use view, it's change in A also affects B, change in B also affects the A. That's two-way, but when you copy, it's just like copying from one to another one. So always check if array has correct data that you are intended to have. In the meantime, when you have copies, it copies the own data, and view does not own the data. But how we can check simple information that is going between copy and view? So every NumPy array has this attribute called base that returns none as a data type if the array owns the data. Let's look at simple example that we have been seeing right now. Let's take this one here, and with this, let's say, okay, b equals a dot copy, which we did just now, and c equals a dot view, which also we saw, and I'm going to print the base of x and base of b and c. Yes, so as you can see, it's returning the type there, and also it's returning the same array for both of that. Yes, the copy returns none value. That's one of the type it is returning. Then comes about, since we talked about indexing, slicing, data types, copy and view, the difference between copy and view, let's talk some aspects of shapes of array, different shapes. When we say shape, you can directly also put it here this way. You can print say a dot shape, because we are going to use this later on when we deal with different arrays. So you can see here, it just simply prints the shape of the array in two-dimensional space. It just gives the number of corresponding elements in the array. So if you have a huge array, then if you want to know the exact amount of elements in the array, it is good for you to use this term space. This actually gives you the, or in other words, it returns you the number of elements there. Yeah, there are many other things that you can perform likewise. Why don't you try different ways so that you can return different elements even in two dimensions? If you are talking about two dimensions, you can also access certain element very specifically. Let's look at more on how we can perform reshaping. We saw shaping. We can also perform a reshaping using this form of arrays. So again, let's take one example here. Let's take this array, and I'm trying to reshape this array. So let's call new a equals a dot reshape. Okay, let's quickly check what is the issue here. The issue here is that we didn't have enough elements in the array, but we are calling for a reshape. Let's add more elements, say 900, 1000, 1100, 1200, 1300. There we are. It has been now printed as the. Here is that we have converted 1D. Initially, a 1D array is given. We have converted the 1D with 12 elements here. Yeah, we have 12 elements into a 2D array. And the outermost dimensions, we have 4 arrays, each with 3 elements. So that's like 4 arrays with 3 elements. So that's just 4. You can see 4 rows with 3 columns. We are just kind of reshaping. How about shaping with 3 dimensions? Let's try again. Let's we have just done with one dimension to two dimension. Let's try one dimension to three dimensions. Let's say okay, how about this one? Here we are. So right now we are actually having the third dimension. We are converting the same 1D array with 12 elements into 3D elements, and this outermost dimension will have two arrays that contains three arrays each with two elements. Yeah, you can see that. That's the idea behind reshaping. And there are many other things you can perform. Maybe you can try to convert 1D array into 2D array with different combinations and check how it works. Also, you can check that copy and view with different arrangements. You can check how it works whenever you copy or view. There are a lot of places sometimes we don't really understand how things works. For example, especially when it comes to certain dimensions which you are not sure, like what is the dimension of the array. In that case, it's very hard for you to specify how to reshape it. So that is one of the challenges people always come across. So at times we also flatten the array by means of converting multi-dimensional array into one-dimensional array. Let's say you have a multi-dimensional array. Let's take a two-dimensional array. Okay, here it is. You have a multi-dimensional array, and you are going to, we have a new array. Reshape. Here it is. The two-dimensional array is being kind of merged to a one-dimensional array. So it is also one of the key factor, because at times we have to reduce the dimensions. There are many techniques we will see specifically how to reduce the dimensions. Like PCA is one of the methods to reduce the dimension when we deal with certain applications. But here it is a very simple one where we have a two-dimensional array and we are going to reduce into a single dimension. When you do that, actually we are performing or in other words, we are reducing the complexity of the system, especially when the array is smaller. And of course, Numpy provides a lot other functions which I'm not covering here. I will of course I won't attach a tutorial for Numpy, so you can have a look at that as you progress with this. So now let's move on to this array manipulation. Now let's move on to iterations, how we can iterate using an array. That would be interesting, isn't it? Let's take this array as an example, which we started with, and let's try to see how we can perform simple iterations. Like for example, if you use a for loop, in this example you can check yeah, that's A. Okay, so again there is some mistakes we have to, small mistakes, sometimes it's just a typo, like here in this case you have a colon here, and I do have simple errors at times I make whenever we have this system here. Let's now do some concatenations. So concatenation is one of the properties that Numpy array operation provides, and this function is very useful to combine two arrays. If you want to combine two arrays, we can actually concatenate. So we have this array A and array B, and we are actually forming, or in other words, concatenating these two arrays into the third one, which is C in this case. Let's try to see how it works. As you can see, this two individual one-dimensional arrays are concatenated, and it has been set here in C, that has been printed. So likewise, we can also do the same thing for a two-dimensional array. Let's take this example. And let's perform a simple operations where a two-dimensional array. Let's have two elements. Okay, let's put the axis here. And let's perform a simple fact, talking about a single dimension. So let's, as we are not using any axis, so let's use a single dimensions, and then you can specify certain values along the way. Okay, for single dimension you don't need these brackets. And basically, could you guess what other, okay, here's another one. Okay, guess again, what is the mistake that we have encountered here? Now let's do this another function called a head stack function, and this function is used to stack along the row wise. So head stack, at times you can say horizontal wise, or in other words row wise. So this is going to be stacked row wise, and the same thing you can do if you want to do it column wise. In other words, you can say it as a V stack. Vertical stack is a column wise operation. There we are. It gets the column wise operation goes on. The same way you can also have a depth wise. So the depth wise is, as you can guess, it goes for D, right? D stack along the depth of the stack. In other words, it's like a height of the stack, you can see, which is same as the depth. So we started with how to manipulate different ways of stacking in this last three functions, and there are more about stacking, joining, or in other words concatenation. We saw the difference between those elements here. Now let's look at how we can split, how to split an array. So if you are given an array, let's say you are given with this array here, and I want to split this array. Okay, this array is given to you, and you want to split into a new array. Let's say new array A equals NP array split. So split the array in three parts. So we are just telling it this way. you're splitting this array into 3 parts. As you can see, there are different elements that we had in hand, and we are splitting up into 3 different parts. So that's the advantage of such things. It's very handy, this function array split. Remember, this function array split has been used here. So this comes in handy in certain applications. So you can also use it while splitting your data. How about if you want to split into 4 parts? Well, try it out. What happens here if you have to put it in, or no, split into 4 parts? Oops. Okay, let's do it again here. There we go. You are splitting it into 4 parts. So this is a simple method of splitting that's very easy for us to adjust the elements. If you know the elements in the row, we can always use the array underscore split function, and it really works properly as just a split function. Even there is a function called split in Python, which is also quite useful function, which can be rearranged in a similar fashion. Okay, now let's see if we can do more operations with this. Let's say I want to do the printing part. As I have splitted the array, I'm thinking of printing it as well. Let's comment this out. Okay, now let's check what is the errors. You can see we are supposed to specify the size of the split. Here we have specified the size of the split, and after which the data in here has been split and been displayed. The 0th is 100, 200, 430, 1 is 500, 600, 700, 2 and 3. That is the split that you have here. So likewise, you can also split the 2-dimensional array. Just take a 2-dimensional array and split. We had some examples of 2-dimensional array in hand. Take some 2-dimensional array and you can split it off. Well, I think you can perform that because of this simple operation. I think you would know how to do it for 2-dimensional array, and you can also use something called a H split. In other words, splitting across the row, or horizontal split, and H stack. Horizontally, you can stack up the values for a given element. So if you want, I can just give you an example on that. Let's move faster. And then you have a new A given here, in which you have NP H split function, in which you have A, 3 say. Okay, so yes, I think I have 2 things here. Okay, there we are. We have in fact split this entire things. So we are performing this method of split, a 2-day array into 2 arrays of along the rows. So we have seen many rows over here because we are splitting along the rows. So similar to this H split, we have H stack. You can stack up along the horizontal, or in other words along the row, and we have V stack. Let me just quickly put it here. H stack, V stack, and D stack, the ones we have performed earlier as well, and we have V split and D split, right? So take your time to check these out, and you can perform more operations using the array operations. Okay, whenever you have an array, you always have an array with many elements in it, and we always wonder like how to find a specific element in an array. So let's take this array. Okay, here it is. Let's take this array, and we want to know certain things in an array. Here we are, and let's say I want to find where is one particular element. Let's say we have a huge array with lots of elements. Say this is a little bit smaller. Just for example, we have taken this small array. Let's say I want to find the value 900 to see where the location of this particular element. I'll say b equals np where right there it is. It is giving us the location of this particular part. Have 4 in our given array. Let's say we are talking about 900, right? Let's put it as 900, and let's try this out. Yes, here we are. This is located in the 7th index, so that is the index where this 900 is located. Isn't it interesting to find a particular location as such? So likewise with indices, you can actually play a lot with specific index. So let's move on and see more on this. Interesting. So I'm going to use the same thing here, but now let me say I want to know the odd numbers and even numbers in this particular array. Let's make some of the odd numbers there, and we'll make sure others are even. So just like in other programming languages, we are going to check for this value, and again, like a small error has come up. Let's try to figure out how to get it to be 2 equals 0. So when you divide by 2, if it is if there is no reminder, then it is going to be an even number. There it is. So all these things 0, 1, 2, then 5, 6, 8, 10, 11, these are the locations in the array, the index where we have the even number. The same is true with odd as well. If you want to find the odd numbers, here we are. You can say we have a reminder, then there it is. There it is. These are the odd number locations. These are very useful for us. In the likewise, you can also perform searching particular value in an array, or you can also use a certain method to search and sort, to perform binary search in the array and return the index. If you just search, a simple binary search can be done by means of sorting. Also, you can, after search, you can also sort the array. So we have a simple function to do that. Let's see how it works with this example here. Let's take another example. In this case, we have say 5, 6, 7, 8, 9. Let's take 4 values here, and b equals search sorted. So search sorted is an function that is inbuilt in Numpy. So we are interested in this particular value, and again let's see, a is given, that is what we have taken here. So with this a in mind, let's try to see again what is the error we have and what it is. Well, as we see, I always make this typo once in a while, and well, we do see this index given for us as we proceed with this. So here the number 7 is inserted in the index 1. That's the kind of things that we want to know, and it also remains sorted at this time, so there is no problem for us. In the same way, you can also search a specific number from a specific side. If you want to search a number from right side of the array, you can also search. If you want to search a number from the left side, or if you have multiple values, you can also do the same thing. Let's do one by one and see how it works. Again, let's take this big array, and with this array, let's try to use a simple method to search dot sort b equals np search sorted. Okay, a, let's say we have say 607. In this location we have 607, and then you can say side equals right. Like we know that 607. Okay, right, there it is. 1 2 3 4 5. Okay, from the right we got it. Let's move on. You can also perform the same thing with multiple operations with multiple indexes. So let's move on, and we'll see how we can sort an array. If you want to sort an array, that's one of the basic algorithm we always go for, right? So let's do a similar methods, which means that we need an array without which is not sorted. So let's take this array and let's mix that up. Okay, so here I'm going to have like 1100, then 200, 5000, then let's say 7000, 9000. Okay, here's the given array, and we are going to have print np sort a, right? Here it is. It is being sorted. 250, 800, 1000. Okay, there it is. It's a simple command, but it's very useful, right? We used to have algorithms for sorting, but it's a very simple function that does the whole thing. Yes, that's one of the advantage again. In the same way, we can try to use all the useful things that you come across in a particular array operation, because Numpy mostly deals with array operation. Let's say we have np array with true, false, and even okay, let's say true. So which means that the array has 3 elements: true, false, and true. Here we'll see how to sort this out. Here we are sorting A. Okay, there we are. We have a simple terms which are missing here. try to figure out what is a simple mistake. Again, A is missing. NP array. Let me check this out. I've been making this mistake several times already, so let's hope you don't make it the same. Here again it has been sorted like false, true, true is another example here. Also, you can do the same operations with two-dimensional sorting for 2 dimensions. Say when you have certain numbers, let's say here, sort A, okay. This is the two-dimensional sorting. As you can see, it's been sorted. The array has been sorted as such. Let's quickly finish some more parts. That's from this Numpy library. Now we are in kind of filtering. Let's see how we can filter an array, especially if we have indexes true, false, like Boolean values as their elements, and is contained, then you can actually filter the array. If the values of the array index is false, that element is excluded from the filtered array. So let's see how it works. Let's take one-dimensional array. Let's take this array here. Okay, maybe I'll change the values. Okay, there we go. So we have 4 elements in this array, and then I'm going to have b equals, let's say, true, false, true, false. There we go. So here we are. We can see these 2 values are printed, like 46 and 81. So can you see the relation from this given example? So because this new filter contains only the values where the filter array had the value true, wherever the value is true for this, it has been taken, like 46 and 81 are the place where it has the value 2, which is index 0 and 2. So that's also very critical if you want to find a special number in a huge array, and if you want to just extract that number out of that array, you can use this strategy to do that. Let's go a little bit deeper into this Numpy application in creating the filter array. It's a simple code for true and false. We just use true and false actually, and we are actually filtering. And this is common to use to create filter array based on this kind of conditions. Let's try a simple filter array with a more bigger codes. This code here, let me explain simply. We have this array A, and you're creating an empty list that we called a filter of this array A, and we are going through each element in the array process. Here we have this element for element in A. If the element is, let's say we have 12 here, the element is greater than 12, set the value true, otherwise false. So let's set it as 12 here and see what happens. Okay, here it is. So you are given with a simple filter. It is actually filtering out, and it's giving you values which is greater than 12. And you also interestingly has this Boolean part, like false, false, true, 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 like, which means that the first two elements, they are not greater than 12, but all other elements, they are greater than 12, so you have true for its name. So likewise, we can also perform another filter. In this filter, let's say you want to use the same code here, and let's say you want to filter out all the even numbers. So I'm going to put this as equals 0. I think that would be fine for the time being. Yes, here we are. So all the even numbers, like except 11 and 23, which are odd, other numbers are displayed: 12, 28, 60, 400. So false, first is false, which is 11 is not an even, false. 23 is not an even, so false. The other things are true. So we are slowly getting into this structure of simple tasks before we move on with this filter information. So there are many other things that you can do with the filter. For example, in this small code that we have here, we can also filter out, let's say here we are. So all things that are greater than 12, I'm directly saying it here. This is a small code than that of the one which we used if-else function, but if you look closely, the results is almost the same. So you can also just simple code can help you to filter out the same way that you used to do. And one of the powerful way in which you can use Numpy is also use random numbers. Yeah, random numbers, when I say random numbers, computer usually use the so-called pseudo-random numbers instead of the true random numbers, because it's very high probability that after, say, billions of numbers or millions of numbers, something is going to happen again. Anyway, for generating the random numbers, we do have simple code that can help us to generate the random numbers. So here it is, random number generator. We do use this function for generating the random. Let's use this function random for generating it. Let me clarify what's getting. Let's talk about this random number. As I see here, one example right away, let's look at. You're going to import this random functions here, and in this case you have integers from 0 to 100. Among those integers 0 to 100, we want 5 random numbers. So here it is, the 5 random numbers were generated out of that. So it's a simple 1D view, right? So likewise, we can also have a 2-dimensional with 3 rows, and each row contains 5 random numbers. So here in this case, you're trying to have 3 rows with 5 random numbers each. There it is. Again, the random number falls within the range of 0 to 100. Likewise, you can also use the general random function, which is as simple as here. Okay, there it is. This is the random function that we use, random.rand5. So 5 random floating points being generated here, this particular one. The same way you can also use for 3 rows, right? You can generate for 3 rows the random numbers. So you can see how this is related, right? So you generate random numbers, and you can also play with the array. So now we have another function called choice, and this function allows you to generate random numbers or random value based on an array of values. So you are given an array. With a given array of values, you are going to generate the random numbers. And this method also helps you to take the array as a parameter and randomly return one value of the given informations. Let's try that out, how to use a random choice within the given array. Here it is, randomly choosing one element from the given thing. So it's like you have a huge array of elements, and you want to pick up one as a sample, or if you want to pick up one randomly, if you want to pick up a number, you can use this one, choice. You're going to choose it, right? So likewise, we can also specify very specifically in detail, like we are given with, again, like 2D array consists of values in the array parameters as we have mentioned here. And again, you can pick up the size. So size here refers as you're adding a size parameter to specify the shape of the array. So your array shape here is 3 rows and 5 columns. That's been generated. Well, as we move in more detailed information, now we are jumping into the probabilities. So as we know that when you come into the probability, we talk about distributions, and mostly right now we'll start with 1D array containing certain values, and then we move ahead and see how things can be performed. Here we go with the first one. Here it is, probability of the values to be like 3, 5, 7, 9. So 3 is said to be 0.1 probability, 3 probability is 0.1, 5 probability is 0.3, 7 probability is 0.6, and 9 probability is 0.0. So here it contains 1D array with 100 values, where each value has to be like 3, 5, 7, or 9, and they have their own probability. Here it is. Yeah, randomly, again, choosing from the given thing. So we have this choice function. So this function allows you to specify the probability of each value, and probability is set by a number between 0 and 1, as we can see there, where we can see when it says 0, it doesn't occur. So that's why in this whole thing you don't see 9. 9 is not occurring, whereas 7 is occurring many times, right? Why is that? The probability is 6. In other words, 60% 9 is occurring. Let's make it a little bit smaller, like 10. Then you will know the difference. The size is 10, but you can see here how it is being defined. As we can see, if you increase the size as say 20, again you can see how it appears. Yeah, so that's again a random choice that you have, and you should always note that sum of probability is 1. So when you add all the probability, it has to be 1. Let's look at some more information. Even if you run the example for like 100 times, in this case 9 will not occur because the probability of 9 is 0. So let's do some more example with the same line of thought. The same example we can use, but now let's return the 2D array with 3 rows containing 5 values. Now we are going to use a 2D array, and you're going to have 3 rows and 5 columns. Here it is, 3 rows and 5 columns with the random distributions, but again you can see 9 is not happening. There is no 9. So let's quickly go through what are the other things we can do. We can shuffle. We can shuffle the array. That's one of the advantage of using the Numpy, shuffling. So let's try that out. So we have this array and a random shuffle. randomly shuffling, and then you're printing the A. Here we are. Initially it's 1 2 3 4 5, and after the random shuffle it is 1 5 3 4 2. That's a simple mechanism of shuffling. You can also perform the permutation and combination. It's again kind of different things that you can look at. Let's try that out. Why don't I print here directly? Okay, print random permutation of A. Here it is. You are printing the random permutation. Again, remember that is the first one is for shuffle, second is the permutation. The two things being printed here. Yes, the permutation method returns the rearranged array. It's again you're going to rearrange the array. So anyway, there's still the original array. That one is over there. We don't have to worry about it. Let's see one more simple information about how to visualize the distribution using Seaborn. Seaborn is one of the basic libraries we often use along with other libraries like matplotlib. The matplotlib is another functions that you can use for plotting. I am not going to talk about plotting in detail today. We will have another class in which I will explain in more detail how to use the matplotlib and Seaborn for various visualization purpose. But just here for us to understand the significance of how we are using it, let's try to use some information of Seaborn as well as let me put as SB. How about SB? Okay, now let's do this one, or you can put it as SNS. So we are going to plot here now and see how this would look. We are trying to plot or displotting this distribution, overall distribution. So here we are, the distributions are plotted. Likewise, you can see more of how we can do this DIST means distribution, and this is the distribution plot. Okay, let's do a histogram and see how it works. So in fact this is with a histogram it comes, and then we want to check without histogram. Yeah, this is without histogram. The histogram is in center. In other words, it's the center part is the mean, and it's showing how much it deviates from that particular location. Yeah, so there are a lot of other things you can check with this kind of simple plots. Let's check out some information about how we can visualize distribution with this example, but we'll also see other distributions like normal distribution, binomial distributions, so on and so forth. So when it comes to normal distribution, you can always use random.norm, like the normal distribution values are given here. This is for the size 2 cross 3. So this is for the size 2 cross 3 that we have here. And you can also randomly, we are still talking about random normal, right? It's a randomly generated values. Likewise, you can generate random normal distribution for any of the size. So how about if you want to visualize the random, this one, normal distribution. Let's try to see it, the random normal distribution. Here we are. This is the random normal distribution for the size given to us, and the histogram is taken out, and you're plotting the graph. So likewise, the curve of this normal distribution is also known as the bell curve, as it looks like a bell-shaped curve. and I think we have already discussed about a little bit of that information. I'm just going to go faster as we move further into this part, because there are normal distribution, then comes the binomial distribution. So if you want to use binomial distribution, the random binomial distributions, here the n value is 10, and here's p value is 0.5 and size is 1000. So given the 1000 as your size, let's put this in the form of a histogram. You can see here 0 to 10 is in the x-axis, and you can count like the 100 size, like 250, 200, 200, 100, 100, and so on and so forth. All together they amounts to, even here there is some values, that amounts to 1000. So there is a simple difference between a binomial distribution and the normal distribution. If you want to check, you can in fact draw one curve or one distribution over the other distribution. So since we talked a little bit about probability, at this time you might be knowing a few things, but in specific you can check what is binomial and normal distribution, because that's not the basic goal for today's lecture. But this is a need for us to know like how they are related with regards to what we are discussing. So we talk about normal distribution, we talk about binomial distribution, then comes the other one, which is called the Poisson's distribution. Maybe it sounds like you studied in your other class, like maybe in your high school or other places we talked about Poisson's distribution. So you can see the same value, which is 1000, given here the lambda is taken as 2, and here we can see the distribution is a little bit different. So basically, as you can see, Poisson's distribution works well for smaller value, if you could recall. And now we can check how the Poisson distribution can work alongside with the normal distribution. Let's plot it out. Show. Here it is, the normal and Poisson's difference, how they are plotted. Likewise, you can also see the difference between binomial and Poisson. Yeah, why don't you try by your own ways? We can see, and try to plot. That's the binomial and the Poisson's distribution. Anyway, with the given data, you can specify what is the difference between them and why at certain locations it's higher than the other distribution. If you are good in the domain in which you are working on, and if you well know the data, what it represents, then you can really figure out the difference between those two kind of distributions. For certain things, some distributions are good. For certain things, other distribution is better. And if you want to visualize, say, you have the uniform distribution, you can also perform the same operation as such as binomial and other things. Here it is. So one thing I want to mention here is we are using the Numpy, and you just go for random binomial, random Poissons, random normal, here random uniform distribution. So you are just plotting the distribution plot. It's so easy to visualize how the distribution would happen. Well, with this again we are drawing without the histogram. Now let's look into another aspect of distribution, which is called a logistic distribution. So that is, again, let's try to visualize it. Here we go. The logistic goes from 0 onwards, hits a peak, and then comes down here again, but it stays in the low part for quite some time. It's a little bit different from other kinds of distribution. if you want, you can compare with the other distribution, like for example, binomial or normal distributions, or like Poisson's distribution. Let's compare with normal distribution here. So we are labeling with normal, and we are trying to do it. Yeah. So these labels are nothing but the legends you are putting here. So we have been putting for some time now. So you can see the difference between the normal and logistic regression is quite obvious in this example. Yes, let's see there is chi-square distribution, exponential distribution. Maybe you are familiar with this exponential distribution, how things might go exponentially. For example, like when you have a disease breakout, then it increases very fast. The number of people infected goes so high exponentially. So in this example, you can see how it goes high exponentially, and then it decay after a certain period of time. So it's a simple way to visualize the exponential distribution. So likewise, there are a lot of other distribution. I don't want to go into detail of all the distribution. Maybe you can check that out. Like for example, chi-square distribution, and there are a few more distributions that you can check out. So overall, we have covered many parts today. Basically, we talked about arrays mostly, and arrays are the basis. Again, we also can see how arrays can be also visualized as a matrix form with rows and columns in it. Yeah. So when you have multi-dimensional array, we can represent that as a matrix, and this is a key part in exploring various datas in real time. So in the coming week, I will give you more instructions on other aspects of computing packages that are available and which can be useful for the course of, for example, if you're working on any machine learning methods. These are some of the bases, and I hope you can try to improve your coding skills when you try to do it by yourself. Yeah. So I like to stop here, and then again we'll catch back with the next lecture. Yeah. Until then, have a nice time. Goodbye.